Hello. Today I have another production job in my non-production machine shop. It's these laser cut blanks, and my job is to drill 4 holes in them. This is the drawing, and there's a hole here, 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 and here. It's 13/64 diameter, and I have to put those in these parts. I had to deburr them first because the laser cut blanks have a bit of a burr on the edge, and that'll affect your setup in the however you fixture it. You don't want to burr because it can push it out of line, and then your hole will be out of position. So the first thing I did was I deburred all the parts. Then I set up in a vise. Just a pretty simple setup to drill the top holes. This isn't the actual setup, but it was similar to this. I've already done that. It was pretty straightforward work, so I didn't bother recording it. But essentially, a bolt to stop down to the mill table, slide this up against it, clamp, drill the hole, move over using the digital readout, drill this hole, unclamp, put the next one in, drill this hole, move over, drill that hole, etc., until they're all done. The second part of this, drilling the holes in the ends, proved to be a little more challenging. And the reason for that, and I've done a couple here, you can see the hole in the end. The reason is just the overall height. It's almost 10 inches tall, and my hand was the vise. You know, you clamp it at the bottom, and the top's pretty unsupported. It could move around when you're trying to drill it and vibrate. But the other problem is, I'm not sure how well this is going to show up on the camera, but all these laser cut blanks, look down at, have warp in them. This one is curving this way. So when you set it up in the vise, it's going to sit over, this is exaggerated, but it's going to sit over like that. And you can come over and pick up the edges with an edge finder and find the center and drill it and position the top of the hole reasonably accurately. The bottom will be out a bit. But the big problem is when you flip this around to drill the other hole, it's now sitting over like this. And now your hole's way out of position. And again, you could pick up the sides, find the center. But the problem there is you got to pick up the sides on every part, and I have quite a few of these parts to do. So what I came up with was this setup. And what I've done is I've taken the box table off my shaper and bolted it down to the the table of the milling machine. And then using the vertical T-slots, bolted my mill to it. And this is it turned out to be pretty good. I've never done this before, and it's worked out pretty good. It's very solid, and the table is square, so I know the vise is, the edge of the bed of the vise here is vertical to the mill table. And what it allows me to do is hold the part right close to the end. And then, even if this has a bit of curvature in it above the jaw, it can't actually move out of position that much when I flip these from end to end. Now, I hadn't counted on this when I set it up. I just sort of got lucky, and it turned out that the jaw lined up with the T-slot in the table, which allowed me to drop it down even more and have the jaw be much closer to this end, which is what you want. It'd be nice if it was right flush with the end, but I don't have any more room on the table to raise this vise up. So being able to bury it in the T-slot has helped quite a bit. The other thing is I don't have to worry about nicking the top of the table. If I put a little nick or something in the bottom of the T-slot, it's not a big deal. What this does, it does 2 things. One, it allows you to hold it closer to the end, so if there is any warp, it doesn't move it out of position so bad. But being able to clamp a good part of it in the vise also straightens this out. The vise just pushes it straight, and this lines up better. And again, allows you to position the hole more accurately. I had to do a little bit of, I've done a few of these, and so far, and I fine-tune the position of the hole I've got it in the center within a couple of thou, which is accurate enough for this job. But it also allows, by using the vise, it allows you to quickly change the part, flip it around, put it in and reclamp it and drill. So this setup, I've done a few so far, and this setup has worked quite well. So I think all that's left to do now is just show you how it works. I'm using the power feed on the mill, and there's a couple of nice things about that. One, it relieves you of the effort of having to actually feed the drill, and two, it gives you a little bit of time while it's drilling to get the next part ready, to just sort of wipe it off with the palm of your hand and make sure there's no crap on it that might affect how it sits in the vise. One done. Holes in each end. And so on. After drilling the holes, the next step is to chamfer the holes. I've already chamfered these after I drilled them, and the one problem is trying to chamfer the backside of the hole is nearly impossible because they're captive, these holes. There's no way to approach them from the backside with anything. I have a back chamfering tool where you put an axle through, and then you slide the chamfering tool on and turn it, and it kind of locks in place. Then you rotate it, draw it back, and it'll chamfer the hole. But it's painfully slow, and I have quite a few of these to do. So what I've done instead was I just took this sort of electric die grinder with a flap wheel on the end, and then just went back and forth here a couple times. And it knocks the burr off. It doesn't chamfer the hole, but it gets the burr off enough that it's smooth and the bolt will fit through properly. As for the the ends, I'll do that on my Fobco drill press. I want to just point out this drill press. I think it's maybe been in a few of my videos before. It's a Fobco 10-8 drill press. made in England. And what's really nice about this drill press compared to new drill presses, first of all, it's just built a lot better. It's quite a bit heavier. It was probably a pretty expensive drill press when it was new. But the second thing is it's got a useful range of speeds. It's got a low speed of 51 RPM. And it gets that from having a 2-speed gearbox in the head. You can select high speed or low speed. And then you can change the belts on top like a regular drill press. It does have a very slick way of tensioning the belt. You just turn this crank and it loosens the belt off. Then you can quickly change it. And then you just turn the crank the other way and it tightens the belt up. It's sort of a scissor mechanism. I had it apart and cleaned it and put it back together, and it works pretty slick. But with the low speed, it's the primary reason I bought this drill press was for chamfering, because with chamfering tools you have to turn at low speed or they vibrate. And the modern drill presses like this that you buy now that are just straight belt driven, the lowest speed is 150 to 200 RPM, and for a lot of chamfering that's just way too fast. So with this drill press being able to go down to, well, 51 RPM, that's pretty good. You can chamfer just about anything on this drill press, and it's not too fast. Now what I've done is, because these parts are tall and skinny, it's hard to hold them straight and stable while you're trying to chamfer the end. So I've decided to clamp them together in groups just to make a more stable setup. There, you can see that that's much quicker even than trying to chamfer on the milling machine, because you can't change position with a milling machine with digital readouts as you can by just sliding the part over and having the counterbore center itself in the hole. This is the reason why I wanted a drill press like this, because I used to chamfer everything in my mill and it just added a lot of time. One other thing I wanted to point out too, I'm not sure what types of counter sinks everybody uses, but I just started using this type with the, if I can get in there to see it, with the hole through it. And they've been excellent. I'm able to chamfer small holes without any chatter at all, like those ones I just did. That was always a problem on the small holes. The other types I used, like the Severance ones, they got about 6 flutes and they're staggered and they're supposed to be vibration free. I found they chatter a lot, and these ones have worked good. I haven't had any chatter, so I'm going to start using these. Probably be the only type I use. In case you're wondering why I'm going through all the trouble of making this setup so that I can drill the holes as quickly as possible, the reason is I don't have just this many to do. I have this many to do. There's 160 of these parts. The current setup results in 320 holes having to be drilled, and a total number of holes that have to be drilled is 640. So it's worth it to take some time to set your machine up so that you can drill as fast as possible. One of the other things I did was, to make it go quicker, was I bought some drill bits that were stub length with a split point end, and that way they'll center themselves, and that eliminates having to center drill each hole, which would essentially double the amount of time it takes, roughly double the amount of time it takes to drill these holes. It was worth it to go buy some new drill bits. They're not that expensive, and it sped up the process quite a bit. The one thing I should have allowed for when I bid this job was enough money to buy myself a straight jacket so the nice people from the Institute could carry me out of my shop in it after I'm done drilling all these holes. Anyways, hopefully I'll stay sane and I'll be able to make more videos in the future. Thanks for watching. Bye.